Okay. So today this is going to be a demonstration on how to do titration. Titration is when we take an acid or a base of a standard solution. In other words, we know its concentration. And then we use one or the other to neutralize one or the other. In other words, when they chemically react, their pHs will change from 1 or 14 to 7. And basically we'll end up with salt water. Today we're going to use a strong base, sodium hydroxide, that has a concentration of 1.0 molarity. That's 1 mole of NaOH in dissolved in 1 liter of water. And we're going to use an acid representing stomach acid, HCl, and we're going to use a 1 molar solution of that. Now, since these are the exact same concentrations and in the balanced equation, 1 mole reacts with 1 mole, then 1 molarity should react with 1 molarity and neutralize each other. The indicator we're going to use is phenolphthalein, and in the presence of a base, that is going to turn pink. To check whether or not we have a base or an acid, we're going to use pH paper, and it has a scale from 1 to 14. If you have a base, it's going to turn a dark purple or a really dark blue, and if you have a strong acid, it's going to turn a bright red. Does anybody want to try checking an acid? Just be careful. Well, you don't have safety glasses on, so maybe we better not. Okay, go ahead. There's a pH paper. There's a strong acid. We'd like to check the base. You can borrow his glasses when he gets back. We're going to use a known concentration, so I'm going to use about 20 milliliters. This is... Okay, the pH paper is right there next to the acid, Eli. Just dip the very end of it in, and then, nope, this is the acid right over here. And compare it to the color scale.
1.
1?
Yeah.
Okay. Strong acids tend to be very close to 1 or below. You just lay the paper down. We'd like to check the base. Thank you, Vinny. This guy right here. All right. Usually, sometimes when the acids are weaker.
13.
13, 14, okay. And that's an indicator of a strong base. What we're going to use is a stirrer, a beaker, a magnetic stirrer, and a clamp and a burette in order to do the titration. We place the stirrer in, it's plastic coated, and it's also a magnet that's plastic coated. We do that so that we're constantly stirring the two mixtures together. With the clamp, what we're going to do first, or with the burette, what we're going to do first is we're going to rinse the inside out to make sure that there isn't any contamination in the burette. You just dump it in the sink. Then you fill it up to 0. You want to do this usually over a sink. Since at your lab stations you can do it over a sink in case you spill. Always make sure that the bottom valve is perpendicular to the burette. That way you're not just pouring it straight on the floor. You can fill it all the way up to the top if you like, or you can just fill it up to some random number that you know you're going to use. In this case, I'm just going to fill it up to a random number that I know I'm going to use that amount. So theoretically, what should happen here is this is representing the stomach acid for our project, and this is representing this solution. The base is representing our antacid. And since they're of equal concentration and equal number of moles, they should if I have 20 milliliters of antacid, it should take 20 milliliters of stomach acid or HCl to neutralize it. What we don't have in there right now, and which is a common mistake that you guys will probably make in your first titrations, is you'll forget to put an indicator in. The reason I chose the antacid to be down here at the bottom is because when you guys are looking at it, that's what you should see before you ever start. So what color is that?
Pink.
About 3 drops is all you need. Its concentration is going to be plenty. Should check to see if that was plugged in. Plenty strong. When you turn on your stirrers, it's going to start really slow. So what you're going to want to do is, these are digital, just about 250 is going to be fine. Just give it a second to start stirring. Note, then the next step you're going to need to do is note with some exactness or some truth what your volume of stomach acid that you have in the burette. You have to jot that down, and then when you finish you'll have another volume and you'll jot that down. You'll subtract the second from the first, and that'll give you the volume of the fluid of the stomach acid that's needed to neutralize it. So I know this is going to use around 20, and I'm starting at 12.3 milliliters, so I'm going to run it down really quickly to about 30. So at 32, we should get a change somewhere in that neighborhood. So you won't know this on yours. You won't know to run it down quickly like this, so you'll just have to let it go a drop at a time. So it's a slow process, so when you get into class you're going to have to start, and you get it all set up, you're going to have to start right away and just let it drip and keep an eye on it. Whoops, and that changed really quickly on me. So my concentrations must not be 1:1. I ended up about 29.7, and if I subtract the two, I must have had either less than 20 milliliters in here, or the concentrations aren't the same, and that's kind of what I can sum up at the end. Any questions?
No.
Okay. What's this called?
pH.
Okay, what's this guy called?
Hot plate.
Hot.
And?
Stir.
What's this guy called?
Burette.
Burette. What's this guy called?
Clamps.
Stand.
Alright. Everybody knows what's fine?
Yeah.
Alright, let's get started.